Hello, everyone. This is the lecture for nomenclature. And so, nomenclature is talking about the way that we name organic compounds. And this is tied pretty closely with the functional group lecture. So, if you haven't watched that yet, make sure you just take a quick look at it. It's very short. But for nomenclature, the main question that we're asking is if we have a structure that looks like this, so as a reminder, looking at our bond line structures. Right. We have every little end of one of these lines is a carbon, and then each of those have the implied hydrogens that are however many bonds are not shown there. So this is just six carbons in a chain, but we have to ask ourselves, what do we call this? Because essentially, without giving it a name, it makes things really hard to identify. But we're going to teach you how to actually name these molecules to make it a lot easier for us to discuss things about organic chemistry in a way that is a scientific way of talking about it. And the actual name of this molecule, I'm going to write it out in a couple colors, is hexane. So hexane, very short and simple, is just six carbons in a straight line. But we have to ask ourselves, how do we get to that point? And in reality, it's a process that's broken down into four different major points that we have to focus on. And I have all four of those points down here. And as I've drawn out the name here, we actually already have three of them shown. So let's look at this little chart and actually talk about how we came to the name hexane. Here, we'll drag this down a little bit. So the first thing that we're looking at whenever we're talking about the structure is in blue over here. And it's the same blue that we were looking at in the name. Essentially, we're looking at the number of carbons, and this gives us a base name for whatever it is we're looking at. And this number of carbons is in what we call the main chain. And we'll take a bigger look at what a main chain is later, but right now, we're just talking about how many carbons are there. So for hexane, we said that there are six, right? We counted them out, and we see that for our base name and number of carbons, it is hex. And that's what we also have in blue up here. So the hex is directly related to how many carbons is in our chain. All right. The second piece is the bond order. And so we're looking at these in terms of single, double, and triple bonds. And for hexane, as we saw, they were all single bonds between the carbons. So because of that, whenever we take a look at the second piece, the single bonds has this infix, which just means that it goes between the base name and what is going to be the suffix, and it is AN. So that's where the AN comes from. That tells us that it's all single bonds. For the third piece, we're looking at a functional group that is present. And so essentially with these, we can either have different functional groups, and you can see all of the ones written out here. You can have anything from carboxylic acids, alcohols, aldehydes, all that stuff. But for this specific one, we're just looking at carbon chains. And carbon chains are alkanes, which means that they are all the way down here in this bottom category of alkanes and miscellaneous, which ends with the suffix E. So putting these three together, we have hex, A-N-E, hexane. And so whenever we're looking at the way that we're going to name these things, we're going to use this system. And you'll notice there's a little fourth thing over here in pink. This is if we have multiple functional groups. So we'll get to those in a second, but for right now, I want to take a look at a couple other compounds and use this system to get down sort of how we name these things. So the next one we'll try is going to just be a very simple compound once again. We'll do this here. So for this compound, once again, we're going to start by looking at how many carbons are in this main chain. And here we see that there are one, two, three, four, and five. And so if we look up here on our chart, five carbons starts with the base name of pent. So that's P-E-N-T. So there's our base name. Now we're looking at the bond order. This is another set of something that has just single bonds. So the second part is our infix AN. And last but not least, it's once again just an alkane, which means it will end with E. So this is pentane, right? Naming alkanes is really easy, but we can take it up a notch. We can mix things up just a little bit. So let's try something a little more difficult that now has a functional group involved. So for this one, we still start out in the exact same method, right? We're looking at what is the base name? How many carbons do we see? And for this one, there's actually only a single carbon right there. And we see that the base name for one carbon is meth. So there we go. We've got meth. Now we're looking at the bond order. There's only single bonds here once again. So that does mean that our infix is an. And then finally, our functional group. This time we have one. And the functional group in this case, we have this OH here that's connected to a carbon. As we talked about in our functional group video, this is an alcohol. And if we take a look at our functional groups over here, we see the alcohol, it's right here in the middle of the list. It has OL as the end. So we'd have that there. So this is methanol, right? So based on all of these things, we can continue naming these molecules, but you'll notice I've been keeping it a little easy, and that's because we need some more information to start naming bigger things. So the first thing we're going to take a look at is what are called locants. And locants are essentially just what we call numbers that locate where something is. So we have to ask ourselves, where is it? And to give you an idea of why this is important, let's say that we were looking at something that was called um, pentanol. So, we have our three different pieces, the pent, the an, and then the all. That tells us that for this first little part here, there's 5 carbons. For the second part, that is telling us that there is just single bonds. And then for the very end, we have an alcohol, right? That is what that functional group tells us. And if we wanted to draw this out, there are multiple options just because we're told it is pentanol. That is without locants, right? So pentanol could be a situation where we have these 5 carbons, and attached to this one, we could have an alcohol. We could also do it where we have the constitutional isomer, where the alcohol is right there. Or we could also do it where we have another constitutional isomer, where the alcohol is right here. So the question becomes, how do we identify these three things as separate from one another? And the answer is by these things we call locants. And so a locant just asks, on what numbered carbon does this reside? So if we look at these different structures and we actually number some carbons out, essentially what we'll find is we'll start over here on the right-hand side, 1, 2, 3, 4, 5. If we were to actually name this top one here, it would technically be pent for the 5 carbons, and because we have just single bonds. But now we can add in a number to show where the alcohol is. And the number is going to go between two hyphens here in the middle, right? So it's on carbon number 1, so we will put a 1 right there, and then we'll put the all afterwards. And so notice that our number is separated from everything else by hyphens. And that is going to be true of every time we name these. So if we take a look at this next one down here and we once again label these carbons in such a way, we see that this is actually pent an hyphen 2 hyphen all because it's on carbon 2. And then the last one, it's right in the middle. This one is pent, oops, and 3 all. Okay? So this is how we're going to be naming these. And you'll notice that I did number these in a slightly specific way. This brings up another rule in terms of how you want to label your locants. So locants, you always want to give them the lowest number possible, right? So always lowest number possible. And if you think about what that would look like over here, we could have labeled these carbon chains as we did, but there was also another possibility. We could have for this top one, the pentan 1 all, We could have labeled it in this other direction, like so, where now the alcohol sits on 5, carbon 5, that would be. And that would be pentan 5-all. But sadly, that doesn't exist because we are always trying to give that locant the lowest number possible. And 1 is lower than 5, so if we can number it that way, that's going to be better off for us. Okay? Now, that being said, locants can be used for more than just the positioning of whatever that group is, right? This is why I haven't brought up anything to do with double bonds yet, but we will now. So let's grab our chart once again, if I can. Oh, nope, not grab. We're gonna grab it and we're gonna copy it. We're gonna bring it down here. We're gonna paste it because this time we're going to see a slightly different writing. So let's say we were looking at a structure that looks like this. Well, now we've changed things up a little bit. We now have a double bond. So if we take a look through everything, right, we first have to figure out how many carbons we have. We have 5. So we still start with the base name of pent, but now with the double bond, we see that right over here, our infix is now changed. It's no longer the AN. We have the EN infix. But just saying pent N is not going to tell us where that double bond is. Because again, it can be anywhere in this molecule. And so the way that we figure that out is we once again have to give it a locant. And we want to give it the lowest number possible. So if we're counting these out, 1, 2, 3, 4, and 5, we can do this way. Or we can do the opposite direction. But the way that alkenes and alkynes work, so those are double and triple bonds, is the number that we give to it for the locant is the carbon that it starts on. All right, so if we numbered it in the black numbering, it would start on the carbon labeled as 2, but in the blue numbering, it would start as the number 3. So in this case, we know that if we want to give it the lowest number possible, the blues do not matter here, right? Because the black numbering gave us the number 2. So we can put in this locant here, that would be pent 2 En, and it's still just alkanes and miscellaneous because that includes alkenes. So it still ends with the E functional group. So this is pent 2-ene. So that's how we're going to be using locants in this case. All right. We're looking at what is the lowest number we can possibly give something, and then we're asking ourselves of how is that going to fit into our little equation here? And that's why I've been doing everything in these different colors, is it shows you where that breaking point is between these different pieces. Now, that being said, there are a couple things left over because we still haven't touched number 4. And the reason is because number 4 is the final thing that we should pay attention to. It's going to be prefixes. But to get to that, we have to understand the idea of having multiple functional groups. And to do that, we're going to talk about the main chain now, right? So we're going to talk a little bit about what is main chains versus side chains. So I've been talking a little bit about what a main chain is, but essentially you can only have a single main chain in a structure, right? That is one main chain always. And the main chain is always defined as the longest carbon chain. So what this looks like is if we're thinking about what this idea could be, we have situations where we could come up with something like this. Right? Looking at this, we can see that there are 7 different carbons, right? We have 1, 2, 3, 4, 5, 6, and 7. But this isn't a heptane, right? Because it's branched. And this is where this concept of main chain versus side chains come in, because you can have one main chain, but you can have many side chains. And the way that we describe these is a little different from just describing main chains. So, if we're looking at a main chain, we're asking ourselves, what is the highest number we can count to on carbons in a straight or bending chain? And we can number this in a couple different ways, so I'm going to do that in different colors. We could do the very simple 1, 2, 3, 4, 5, and 6. So 6 is the highest number that we've gotten to so far. Right, we could have labeled it 1, 2, 3, 4, like that in blue, but that's only 4, which means it's not necessarily a main chain. And then we could do in red here, which would be 1, 2, 3, 4, 5, but that's once again 5, so it's not a main chain. So essentially what we can boil this down to is looking over here, the chain with 6 is the one that we are calling our main chain, right? Any other carbons that are not included in those 6 are a part of what we would call a side chain. So if we take a look down here, this carbon right here is the only one not included in those 6. This is our side chain. So the way that this works in terms of nomenclature is the main chain actually takes precedence in terms of our base name. So as a reminder, for 6 carbons, that is hex. And as a matter of fact, it actually matters as well in terms of everything else. Because if we're taking a look at our other pieces, we still see that there's only single bonds. So that's AN. And there's only alkanes. So it's E. But as we know, this isn't just hexane. There's something else. And that is where this last piece of the puzzle comes in. Right? Let's get this table right back down here for us. So looking at this, we now have this fourth piece that's going to come into play. And that fourth piece is our prefixes. And prefixes are essentially there for when you have multiple functional groups. So the main chain functional group here was just an alkane. And you'll notice that in here, in this fourth spot, there is also a spot for alkanes. And that is because if your side chains are alkanes, you also have to name those. And how this works is essentially, it says right here, it's the base name plus YL. So if we take a look back up here at our structure, we have a single carbon there. And the single carbon base name, as we see over here, is meth. So we're taking that base name, meth, and we're adding on the YL that we see down there in the fourth column. So it is methyl. And that, as a prefix, is going to come before our hexane. But that being said, it's not just methylhexane, right? Again, these nomenclature rules stack. We now have to give it a locant. So we have to give it that number. And once again, we're looking for the lowest possible number we can give it. So let me just redraw out this structure since we have a bunch of numbers on it. Remember, we can number it from left to right here, or from right to left. But our locant is the one that is the lowest number possible, and we see that the methyl group is on carbon 3. So whenever we put the locant in, this is 3-methyl hexane. So this is kind of how main chains work versus side chains. But you can notice that things can start to get very complicated very quickly. But let's take a look at another example of this, where we're looking at something that's a little larger and a little more complex, but it is still going to follow the same rules. So if we take a look at this structure here, now we have a lot more twisting and turning than we did in the previous structures that we were looking at. But the first thing we need to do is we need to find out where is the longest possible carbon chain, right? So if we take a look up top here, we can write out 1, 2, 3, 4, and 5. So 5 is our current maximum. If we were to split from where that 3 is and go down here, we could do 4, 5, right? But we could also do a little bit of a turnaround and get up to a count of 7. All right. And this 7 is actually the longest chain that we can get. So we can erase these other numbers. If we're looking at this in terms of a longest chain, it's that 7, which means that this is a hept, right? That's what 7 shows for our number of carbons with base name. So we've got hept, and we see that there are no alkenes or alkynes, no double or triple bonds. So it has that infix of AN. And then there's only alkanes, which means that it ends with E. But now, if we take a look at our prefixes, we notice that there are now 2 different side chains. And if there are 2 different side chains, right, we have this side chain and this side chain, Two side chains means that we will have two prefixes. All right. So these prefixes are determined separately. So taking a look at the one on the top, we see that up here there are two carbons in this side chain, which means that it is going to be F, and then you add on the YL for the prefix. So this chain here is an ethyl. The one down on the bottom, it's a single carbon. It's like we saw last time, methyl. But now we have to, once again, put in their locants, and we have to follow one other rule. Right? Again, these rules start to stack on pretty quickly. The final rule is very simple, though. Alphabetics is important. So if you have multiple prefixes, essentially whichever one's alphabetically first, we're going to put first. So if we're talking about ethyl versus methyl, ethyl's going to win because E comes before M in the alphabet. So, with that being said, if we wanted to put down the full name of this molecule, it's going to be 3-ethyl, right? Because that ethyl comes first due to alphabetics. 4-methyl heptane, right? So we have to have the locants, we have to have the prefixes, we have to have them in alphabetical order. You need the main chain and then any other functional groups. Okay? So, with that being said, there are a couple other rules, but these are going to be relatively simple by comparison. So the last rule that we need to talk about is called priority. And what priority is pretty much saying is some things are more important. All right? So, what does priority actually mean for this entire chart here? Well, essentially, what we're saying is that some prefixes are more important than others, some suffixes are more important than others. All right. And so looking at this, it's actually very simple. They're already in order. So if you look at these from top to bottom, they are essentially the top is the highest priority, right? So highest priority is all the way up at the top. And this is inclusive for all of these lists here. Right? As we go up, we have higher priority. And the reason this matters is because of situations we can get into that look a little bit like this. Right? If we take a look at this structure and we want to name it, the first thing that we have to do is we have to number the longest carbon chain. And if we number it, we can number from left to right, and we see that it is a 5 carbon chain. There's no tricks being played here. If you number it in the opposite direction, it is a 5 carbon chain. So we're looking at what we can give the lowest number, but we see that in the situation of the blue chain, we have something on carbon 2, we have something on carbon 4. In the red chain, we have something on carbon 2 and this something on carbon 4. So we have to ask ourselves, who wins in terms of taking the numbers? And that has to do with our priority up here. So what you do whenever you're looking at priority is you identify where are things on the functional group list in terms of which one matters more. And so in this case, we have an alcohol, right? That is this one right over here. And then we have a ketone, which is that carbon double bonded to oxygen. And so if we take a look at where those lie, the ketone is right here in our functional group ranking, and the alcohol is just below it. So essentially what we're saying here is that the ketone matters more than the alcohol. So when we are naming this, we also need to keep that in mind. So the appropriate way that we can number this chain is we have to give the ketone the lower number. So that means that if we can put the ketone on 2, such as numbering from right to left, that's what we're going to do. The other thing you have to keep in mind with this is that the suffix happens before the prefix. Hence why they're in this order one, two, three, four. So whenever you have multiple functional groups, like we have a ketone and an alcohol, you can only have a single suffix, right? Only one is allowed. But you can have multiple prefixes, right? So multiple of these are allowed, which is what we saw last time whenever we were looking at both the methyl and the ethyl chain. We can have multiple prefixes, but we can only have one suffix. And since the suffix is more important, it also goes with the priority thing. So that being said, whenever we're taking a look at the name of this, the ketone is going to be the thing that gives us our suffix, and then the alcohol is going to give us our prefix. So what that'll give us is a structure that's going to be named. First of all, we're looking at our carbon chain. It is five. As we've seen multiple times, that is pent. There are no double bonds in terms of between carbons. All right, that is what that middle part is talking about. It's double bonds between carbons, not between like carbons and oxygens. So the ketone doesn't make a difference for it. So the infix is still the AN because all the carbon bonds are single bonds to the other carbons. Our suffix, though, is going to be for the ketone. So it is going to be -one. Keep in mind that we do have to include the locant, right? Because it is on carbon 2, so it's 2-one. And then we get to put in our prefix, which in this case is going to be for the alcohol, as we saw. And the alcohol prefix is hydroxy. But once again, we do have to identify where that is. It's on carbon 4. So this is 4 hyphen hydroxy pentan to own. All right. There's not actually a space here, by the way. It is just due to the way that I wrote this in. So, that being said, this is really almost all of the important rules of nomenclature. All right. It's alphabetics, locants, priority, and making sure that you always have that longest carbon chain. With that being said, I highly recommend taking the time to attempt the nomenclature practice problem set because it will get you very familiar very quickly with all of the different nomenclature rules, and it will also help you get a little bit more in touch with all the functional groups so that you actually learn them and you can start to memorize those for the exam. With that being said, there's not really anything else to talk about here. Next time, we will be going in and we'll be talking about some of the stuff that we skipped over in chapter one. Primarily, we're going to be going back and we're going to start looking at what is called hybridization. See you next time.